Okay, we're going to look at how you can impress your friends with this cool formula for multiplication. We're going to see where it comes from and actually what sort of puzzles can you use it from, and then we're sort of going to build it ourselves. So we're going to start with this puzzle here. Without calculating the 5 products below, put them in order of size from smallest to largest. Now, what's nice about these is that they're all symmetrical. And they're all symmetrical around the same number. They're all symmetrical around 200. So why don't you pause the video and try it yourself? Okay, so we're going to go through it. This first one can be written as 200 plus 10 multiplied by 200 minus 10. This next one can be written as 200 minus 5 times 200 plus 5. The next one, 200 minus 2 times 200 plus 2, then 200 minus 14 times 200 plus 14, and finally this one is just, well, 200 squared. Now how does that help us? Well, it helps us because of our difference of two squares formula, which is that if you multiply together the sum and the difference of two numbers, so a plus b or a minus b, so for example up here 200 plus 10 times 200 minus 10, you end up with a squared minus b squared, a difference of two square numbers. So this one is just going to be 200 squared minus 10 squared. So this first one we can write as 200 squared minus 10 squared. The next one we can write as 200 squared minus 5 squared. This one is 200 squared minus 2 squared, 200 squared minus 14 squared, and 200 squared. Now we can see how this can help us put them in order of size. Because we're just going to see how far away or how much are we taking away from 200. So if we want to start with the smallest, let's change colour. The smallest, well, that's going to be this one. This is our smallest because I'm taking away 14 squared from 200 squared. Then it's going to be this one because I'm taking away 10 squared. Then this one. Then this one. And finally, our biggest one is just 200 squared because I'm not taking anything away. Now what we actually did here is we used this formula without really realizing it. And we're going to see why on the next slide. Actually, in part 2. Part 2. So, we got this formula. So let's look at one of our examples from the previous page. Let's look at 186 times 214. The first thing we did is we wanted to find what is the value in the middle? What was that first number that both of these are symmetrical around? And to do that, we find the middle. To find the middle of two numbers, we add them together and divide by 2, which gives me 200. Sometimes you can do this just by looking at them, but it's nice to have a formal method. We add them together, if this is A and this is B, and we divide it by 2. So we've got A plus B over 2. That is the first thing I'm doing. And then I'm subtracting something and I'm adding something, and I want to subtract and add the same thing because both these numbers are going to be the same distance away from 200 because we found their middle. That distance is just going to be the difference between the bigger one and the middle. Now if we call the bigger one B in this case, we can have that what's going to go here, this difference is just going to be B, the bigger one, minus that middle. Now we can simplify this. We've got B over 2 minus A plus B over 2, which is just, 2B over 2 minus that, which is 2B minus A minus B all over 2, which is just B minus A over 2. It's actually the difference of the two numbers divided by 2. The difference between these two is 28. Divide that by 2, that will give me the difference between the middle and the top one. So going back to our formula here, we can rewrite this as A plus B over 2 minus B minus A over 2 plus B minus A over 2 here. And how do we get to our final formula? Well, we just use our difference of two squares. It's just, let's do a different color pen. We know that a squared minus b squared equals a plus b times a minus b. So we've got this times this. So we've got a plus b over 2 squared minus this times this, b minus a over 2 squared. So there we go. We've changed every multiplication into this formula. Every single multiplication. So let's use it. Let's grab this guy. Let's grab him. Can we grab him? Nope. Yeah, I bet we can. Let's grab him. Oh, we can actually copy him. Okay. Anyway, doesn't matter. Got this guy. And let's look at any two numbers. Let's go for 25 times 32. Or 37. 37. So we start by adding them together and dividing by 2. So 25 plus 37 over 2 squared minus 37 minus 25 over 2 squared, which gives me, well, that's going to be 62 over 2, 31 squared minus 6 squared. So this is actually exactly the same as 31 squared minus 6 squared, which is kind of neat. It's a nice way of writing a multiplication as a difference of two numbers. And we can see why that might be useful up here in this problem. So without writing or using a calculator performing any long multiplication, find this value. Now this is nice because it's got a symmetry. We're finding the multiplication of two numbers. Now using our formula, we know that a times b is just a plus b over 2 squared minus a minus b over 2 squared. Actually, this should be b minus a, the big one minus the smallest one. So let's do it. We've got 2015 times 2017 divided by 2. And actually, because we're just finding the middle here, it might be obvious to you that it's just 2016 minus the difference over 2 squared minus 1 squared. So we can write this whole thing as just 2016 squared minus 1 squared minus 2016 squared. And then these just cancel. We're left with just minus 1 squared, which is minus 1. So this whole calculation is just equal to minus 1. Pretty neat. We could have done that for anything. Let's say we had 2016 times 2018 minus, well, what would we have to minus to end up with minus 1? 2017 squared. That's 2017 squared minus 1 squared minus 2017 squared. But this is just this. You just get minus 1. How neat is that? So next time you're doing a multiplication, see if you can use this funky new formula to do it. See if it feels fun, see if it feels useful, and I'll see you in the next one. And subscribe for more maths.